The next question, that is question number 21. One vertex of an equilateral triangle is at origin and the other two vertices are of course the roots of the equation 2z square plus 2z plus k is equal to 0. Then what is the value of k? He is asking us. So the value of k, option A is 1, option B is 1 by 3, option C is 2 by 3 and option D is 1 by 2. Let us have a check for that. Let us observe that carefully. One vertex is at origin. The other two vertices are of course the roots of an equation has been given. What is that equation? 2z square plus 2z plus k is equal to 0. We are supposed to know the value of k. How? Let me call the other two vertices a and b. How to get a and b? They are the roots of the equation. What is that equation? 2z square plus 2z plus k is equal to 0, plus k is equal to 0. Then k is, what is z here? Actually, z is a complex number, z is equal to minus b plus or minus root of b square minus 4ac, that is 8k by 2. We are sure that it is not real. Therefore, this can again be taken as minus 2 plus or minus square root of minus 1 into 8k minus 4 by 2. Why? Because as it is a complex number, this 4 minus 8k is definitely less than 0. You have to observe that 4 minus 8k is less than 0. That is 4 is less than 8k. That is k is greater than half. You please mind this in your mind. K must be greater than half. So that this can again be taken as minus 2 plus or minus. Let me get 4 out so that it becomes 2i into root of 2k minus 1 by 2. You can cancel 2 here. This is minus 1 plus or minus by 2a, that is 2a. Therefore, minus 1 plus or minus I root 2k minus 1 by 2. By looking at this, we can trace a and b. How? A is equal to minus 1 by 2 plus root 2k minus 1 by 2 and b is equal to minus 1 by 2 minus root 2k minus 1 by 2 and the third vertex is origin. We believe that these three are of course the vertices of an equilateral triangle. So that we must be having OA is equal to OB is equal to AB, isn't it? OA is equal to OB is equal to AB, right? OA is equal to OB is equal to AB. What is OA? Similarly, OA square is equal to OB square is equal to AB square. What is OA square? 1 by 4 plus 2k minus 1 by 4, isn't it? Just like that, OB is also 1 by 4 plus 2k minus 1 by 4. Okay, OA square is 1 by 4 plus 2k minus 1 by 4 is equal to AB square. What is AB? Difference is 0 and difference is 2 root 2k minus 1 by 2. 2 and 2 will be cancelled, leaving you 2k minus 1. Isn't it? This minus this whole square is 0. This minus of this is root 2k minus 1 by 2 plus root 2k minus 1 by 2 is root 2k minus 1 whole square is nothing but 2k minus 1. 2k minus 1. Multiply with 4. What is going to happen? 1 plus 2k minus 1 is equal to 8k minus 4. 8k minus 4. Yes, 1 and 1 will go away. Therefore, 2k, you send that right. Bring 4 this side. 4 is equal to 6k, or k is equal to 4 by 6 or 2 by 3. Is it available? Of course available in the option C. That is the third option. Answer is 2 by 3. The value of k is 2 by 3. Value of k is 2 by 3. Yes. Here we would have made use of the character of equilateral triangle. That is, all the sides are equal. We see that both y and OB are equal to 1 by 4 plus 2k minus 1 by 4 under root, and AB is of course root 2k minus 1, by equaling which we are able to get k. At the same time, you must be knowing the style of getting z here. As you believe that z is a complex number, you must be able to write this in terms of I root something like that. Then only you will be able to have A and B, the three vertices. After producing the vertices by making use of their lengths are equal in the equilateral triangle, we can get k as 2 by 3. Therefore, option C, that is k is equal to 2 by 3, is the right answer. Let us now see the next question, that is question number 22. Log to the base tan 30 degrees of 2 mod z square plus 2 mod z minus 3 by mod z plus 1 is less than minus 2 he has given. With that constraint, what must be satisfied, he is asking us. And he likes to explain that consequence in 4 options. Among them, the first option is mod z is less than 3 by 2, mod z is greater than 3 by 2, mod z is greater than 2, and mod z is less than 2. What should happen? Let us observe. Well, what is the constraint given? Let us understand it carefully. Log of to the base tan 30 degrees of 2 into mod z square plus 2 into mod z minus 3 by mod z plus 1 is less than minus 2. First of all, what is tan 30 degrees? Tan 30 degrees is 1 by root 3, isn't it? Therefore, log to the base 1 by root 3 of 2 mod z square plus 2 mod z minus 3 by mod z plus 1 is less than minus 2. Well, my dear, let us recall the properties of logarithmic function. As and when the base is greater than 1, logarithmic function is an increasing function. Whereas when the base lies between 0 and 1, the logarithmic function is a decreasing function. What I mean to say is x less than y if and only if log x to the base a less than log y to the base a, x greater than 0, y greater than 0, a greater than 1. Whenever the base is greater than 1. Similarly, x is greater than y implies log x to the base a is greater than log y to the base a. Same inequality will be maintained. Whereas x greater than 0, y greater than 0, 0 less than a less than 1, then x less than y if and only if log x to the base a greater than log y to the base a. That is the character of an increasing function. This is the character of a decreasing function. Therefore, we recall the properties of a logarithmic function. It behaves just like as an increasing function as and when the base is greater than 1. And as if you observe that the base lies between 0 and 1, it behaves just like a decreasing function. Now, 1 by root 3, is it less than 1 or greater than 1? It is less than 1. It lies between 0 and 1. Therefore, this is 1 by root 3, it is less than 1. Hence, using the character of a decreasing function, what can you say? This is 2 mod z square plus 2 mod z minus 3 by mod z plus 1 is greater than 1 by root 3 whole to the power of minus 2. That is, I like to convert this in terms of index notation. What is 1 by root 3 whole power minus 2? It's just nothing but root 3 whole square is nothing but 3. Yes, of course, it is 3. That is 2 mod z square plus 2 mod z minus 3 is greater than 3 into mod z plus 1. I think you believe that this is 3. 1 by root 3 whole power minus 2 is nothing but root 3 whole square is nothing but 3. So 3 into mod z plus 1. You bring all of them in this side. What is going to happen? 2 mod z square plus 2 mod z minus 3 mod z minus 3 minus 3 greater than 0. Already it is minus 3. There these 3 ones are 3. It comes here, so that it becomes again minus 3. That is, now let me omit these two so that further simplification is needed. That is 2 mod z square plus 2 mod z minus 3 mod z is minus mod z minus 6 is greater than 0. It's very simple. It can be factorized. It can be factorized. So that the factors will be mod z minus 2 into 2 mod z plus 3 greater than 0. From that, from the knowledge of quadratic expressions, or even you apply the scheme of signs, you say that mod z is either less than minus 3 by 2 or mod z is either greater than 2. Anybody, every person can say that this is impossible because modulus of a complex number is of course a non-negative real number. Hence it can never lie beyond minus 3 by 2. It cannot be negative. As this is impossible, what must happen? Mod z is greater than 2. Is it available in the among options? Yes, it is available among the given options. Mod z is greater than 2. Hence, the right option is option C is the correct option, and the right answer is mod z greater than 2. The next question is question number 23. The number of common roots of the equations x cube plus 2x square plus 2x plus 1 is equal to 0 and x power 2012 plus x power 2014 plus 1 is equal to 0. Yes, let us have a look over the two equations. The number of common roots is asking. You see, the first equation is a third degree equation. The second equation is a degree of 2012. If at all common roots do exist, at most 3 common roots. That's all because the first equation is of third degree. Let us see what happens. Let us observe the two equations given. By the way, the options are, the first option is 1. It says that only come one common root. Second option is 2. Third option is 3. Fourth option is 4. 4 is definitely wrong. Why? Because the first equation is of third degree only. How can you get 4 common roots? It is impossible. Okay, let us see. The first equation, what is that? X cube plus 2x square plus 2x plus 1 is equal to 0. X cube plus 2x square plus 2x plus 1 is equal to 0. You observe, sum of the coefficients of odd powers of x is 3. That of even powers of x is 3. 3, 3 equal. What do you understand? X plus 1 is a factor, no doubt about it. X plus 1 is a factor. X plus 1 is a factor. That is, it can be split. Of course, you can use synthetic division or whatever means you have with you. You divide with x plus 1 or something like that. You will be able to write this as x plus 1 into x square plus x plus 1 is equal to 0. It's very simple and clear. You can use synthetic division or any other means, or simply divide with x plus 1. Usual algebraic division you can use so that you believe that this can be written like this. You see that. No need to believe. You can see that this can be written like this. X plus 1 into x square plus x plus 1 is equal to 0. Well, what are the roots of this equation? Roots of x plus 1 is equal to 0 means x is equal to minus 1. Roots of x square plus x plus 1 is equal to 0. It is a famous equation which has the complex cube roots of unity. Omega and omega square are the roots as the roots. Well, we could have got, what are the roots? Minus 1, omega and omega square are the roots of the first equation. If at all the two equations have common root or roots, those must be among these three only. Well, what is the second equation? What is the second equation? X power 2012 plus x power 2014 plus 1 is equal to 0. Let us test it. Let me name this sum f of x. You first substitute, is the x is equal to minus 1. You first substitute f of minus 1. Can it be 0? Minus 1 whole power an even number, it is 1. Minus 1 whole power an even number, it is 1. 1 plus 1 is not 0. Hence it is not equal to 0. Hence minus 1 is not a common root. Omit it. Only two possibilities are there. What are they? Omega and omega square. Let us now have f of omega. What is f of omega? Omega power 2012 plus omega power 2014 plus 1. By the by, 2 plus 1 plus 2 is 5. Sum of the digits is 5. It does mean that it is not a multiple of 3. It's not a multiple of 3. Therefore, I can write this as omega power 2010 into omega square plus here 2 plus 1 plus 4. How much? 7. Is it a multiple of 3? Even that is not a multiple of 3. Therefore, I like to write this as omega power 2013 into omega power 1 plus 1. Look at this, 2010, it is a multiple of 3. As it is a multiple of 3 occurs as the exponent for omega. You say, you see, you believe, you use that this is 1. Hence, this is equal to 1 into omega square plus 1 into omega plus 1. Hence, omega square plus omega plus 1 is equal to 0. Successful. We could have noticed that omega is a common root. Still, there is a small, the activity is remained for us. You may have to test whether omega square is also a common root or not. Let us do that. F of omega square. What is f of omega square? Omega square power 2012 plus omega power 2014 plus 1. Omega square power. As in the previous case, it can be written omega power 2 into 2012 is 4024 plus omega power 4028 plus 1. Observe this, 4 plus 4 plus 2, 10. Is it a multiple of 3? No, it's not a multiple of 3. Therefore, I like to write this as omega power 4023 into omega power 1 plus just like this, 4028, 4 plus 2, 6, 6 plus 8, 14. Is it a multiple of 3? No, it's not a multiple of 3. So, I like to write it as 4026 into omega square plus 1. You observe the style of writing this. I have split this in such a way that I am able to get a multiple of 3 here. 4023. 4 plus 2, 6 plus 3 is 9 is a multiple of 3. Sum is divisible by 3 and the total number is divisible by 3. Hence it is a multiple of 3 and omega power a multiple of 3 is surely 1. 1 into omega. Omega. 1 into omega square. Is it a multiple of 3? Yes, of course. I could have split that in such a way that I'm able to get a multiple of 3. I'm able to get a multiple of 3. That is why this is also 1. 1 into omega square is omega square. Omega square plus 1 is again 0. Successful. F of omega is 0 and f of omega square is also 0. Therefore, how many common roots are there for the given two equations? Just 2 common roots are there. Therefore, what is the right option? Option B is the right option. Here, the crucial thing is you have to decide the roots of this equation in the beginning itself. And the luckiest thing is you can notice that x plus 1 is a factor for this expression in the left hand side. So that it is found easy to split it like this. And the 3 roots are like this. Clearly, minus 1 does not satisfy that, whereas omega and omega square are satisfying that. The number of common roots is therefore 2 only. Only 2 common roots are there. That is option B is the correct option. We shall now see the next question before us, that is 24. Question number 24. He is giving us mod z is equal to minimum of mod z minus 1 and mod z plus 1. Mod z minus 1 and mod z plus 1. Minimum of those two is mod z. Then what is mod z plus z bar? He is asking us. Z plus z bar in the sense z plus z bar we want to have. Let us see. What is given? Mod z is equal to minimum of mod z minus 1 mod z plus 1. What is asked here? Mod z plus z bar we want. Mod z plus z bar. What is mod z plus z bar? If z is x plus iy, z bar is x minus iy, z plus z bar is 2x, that is 2 into real part of z. 2 into real part of z. Isn't it? Okay. Let z is equal to x plus iy implies z bar is equal to x minus iy. We can easily recollect that z plus z bar is 2x, that is 2 into real part of z. And of course z minus z bar is 2iy, that is 2i into imaginary part of z. Of course here we are interested to have z plus z bar only. That is why in the beginning itself we could have got z plus z bar as a rough estimate, that is 2x. Okay. What are the cases that may happen here? Mod z is minimum of this or this. Therefore, mod z can be either mod z minus 1 or mod z plus 1, which is the minimum. That value will be taken by mod z. So, 2 cases will arise here. Case 1. What is case 1? Mod z is equal to mod z minus 1. Implies mod x plus iy is equal to mod x plus iy minus 1. Here it is root of x square plus y square, and there it is root of x minus 1 whole square plus y square. If you square on both sides, what happens? Y square will be cancelled, leaving you x square is equal to x minus 1 whole square. X square is equal to x minus 1 whole square. That is x square is equal to x square minus 2x plus 1. If you cancel x square, what do you have? Minus 2x plus 1 is equal to 0. That is 2x is equal to 1. What is 2x actually? Z plus z bar. Therefore, z plus z bar is equal to 1. Therefore, in the first case, that is case 1, that is when mod z is mod z minus 1, we are able to have z plus z bar is 1. Actually speaking, you can stop doing it. Why? Because z plus z bar is 1 implies mod z plus z bar is 1, and there is only one option containing 1, that is option A, and the luckiest thing here is there is no option none. One of those 4 options must be correct. Therefore, option A is correct. Option A is correct. Of course, for our sake, to know the other case only, we study theoretically. Of course, here itself we are able to say that the answer is 1, that is our first option. Correct. Let me see the second case also. What is the second case? Case 2. Mod z is equal to mod z plus 1. Mod z is equal to mod z plus 1. In this case, we can observe mod z square is equal to mod z plus 1 square. What is mod z square? X square plus y square. What is z plus 1 whole square? X plus 1 whole square plus y square. Y square will go away. X plus 1 square is equal to x square. X square also can be cancelled, so that you will be having 2x plus 1 is equal to 0. That is 2x is equal to minus 1. What is 2x actually? Z plus z bar is equal to minus 1. What is mod z plus z bar? Modulus of minus 1. It is 1. So, in both the cases, in the first case and the second case also, mod z plus z bar is 1. Actually, z plus z bar is plus or minus 1. So, z plus z bar is purely real. Why? Because z plus z bar is nothing but 2 into real part of z. Real part of z in the sense it is a real number. So z plus z bar is 1 or minus 1. Hence mod z plus z bar is 1 according to our theoretical discussion. Actually speaking, here itself we could have got the correct answer as 1. Why? Because z plus z bar is 1 implies mod z plus z bar is also 1. And there is one and only one option containing 1, that is option A is the correct answer for this question. The next question is, that is 25th question. If the roots of the equation z cube plus iz square plus 2i is equal to 0 represent the vertices of a triangle ABC in the orgone plane, then the area of the triangle is in square units is asking us. Of course, the options are 3, 1, 4, 2 in square units. We have to find the area, and to have the area we must be able to have the 3 roots of the given cubic equation in complex numbers. Unless or otherwise you cannot have the 3 vertices of the triangle whose area is required. So let us observe the given equation. What is the given equation? Z cube plus iz square plus 2i is equal to 0. To solve a cubic equation either in real number system or in complex number system, we have a particular mechanism and rules and regulations like that. But you see, in competitive examinations like this, questions of this sort, he definitely gives some simple clue in that. You substitute either 1 or minus 1 or I or minus I as these are complex numbers. You have a trial. 1 is not a root. Minus 1 cannot be a root because I is there. As it is a complex constant, you have a trial in terms of complex numbers. You put z is equal to I, have a trial. I cube is minus I square is minus 1 into I, minus I, minus I, minus I, minus 2I. Minus 2i plus 2i is 0. We feel happy. We should feel happy. As z is equal to I is a root. Hence it can be factorized. Z minus I is a factor. Z minus I is a factor. It is sure to observe. Z minus I is a factor. And what is the other factor? You can use synthetic division or any other method you have in your hand. So we have noticed that z is equal to I satisfies this equation. Hence z minus I is a factor of this. It can be factorized as z minus I into z square plus 2iz minus 2 is equal to 0. You can easily observe. You can check even. By using synthetic division or any other means, you have z cube plus 2iz square minus iz square is 2iz minus 2I plus sf is equal to 0. Well, what are the roots of this equation? Plus z is equal to I or z is equal to minus b plus or minus root of b square 4i square minus 4ab. 4ab is minus 8 by 2a. This is minus 2i plus or minus plus 8 minus 4 is 2. Plus 8 minus 4 is 4 and root is 2 by 2. This is minus I plus or minus 1 is equal to minus I plus 1 or minus I minus 1. Minus I minus 1. Successful. We are able to have the three roots, means the three vertices of the triangle. The first root is I. Corresponding to this complex number, the point on the orgone plane is 0, 1. Corresponding to the complex number 1 minus 1. Minus 1 plus I is nothing but 1 minus I. 1 minus 1, the point is 1 comma minus 1. And for this minus 1 minus I, it is just nothing but minus 1 comma minus 1. Successful. We are able to have the three vertices. If three vertices are there, we have a beautiful formula to have the answer. What is that? Area. Required area is equal to half into it. You convert, you shift the horizon to any point you like. To this point I like to. 0 minus 1 is minus 1. 1 minus of minus 1 is 2. 0 minus minus 1 is 1. 1 minus of minus 1 is 2. Is equal to half into minus 2 is minus 4. Mod minus 4 is, as it is area, it must be expressed in positive square units. So it is 4. Half into 4 is 2 square units. Is it available? Of course it is in the option D. The main thing here is you are supposed to get the roots of this equation. In our real classes, whenever x is a real variable, we could have used a trial and error method to take x equal to 1, minus 1, 2, minus like that. But here we are dealing with complex number system. You have a trial for z is equal to I minus I like that. Successfully, we could have noticed that z is equal to I is a root, that is z minus 1 is a factor, z minus I is a factor, and you can trace the second factor also, which is a quadratic factor, thereby having the three roots of this equation which correspond to the three vertices. By the way, what are the roots? Z is equal to I, 0, 1. Z is equal to 1 minus I, 1 minus 1. Z is equal to minus 1 minus I, minus 1 minus 1 is the point corresponding to that complex number on the orgone plane. We could have traced the three vertices and thereby you got the result. Area of the triangle is half into 2. That is half into 4, that is 2 square units. That's all the answer for that. Right option is D and the right answer is 2 square units. Let us see the next question, that is question number 26. In this question, if n is greater than or equal to 3 and 1, alpha 2, alpha 3, etc., alpha and minus 1 are nth roots of unity, then the value of sigma alpha I, alpha j, I and j run from 1 to n minus 1 in the increasing order. That is 1 less than or equal to I less than j less than or equal to n minus 1 is. First of all, what are 1 alpha 2, etc., alpha and minus 1? It has been given that they are nth roots of unity. What do you mean by nth roots of unity? They are nothing but the roots of the equation x power n is equal to 1. 1 alpha 1 alpha 2, etc. alpha n minus 1 are the roots of x power n is equal to 1. That is x power n minus 1 is equal to 0. Therefore, we can write x power n minus 1 is equal to x minus 1 into x minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus of alpha n minus 1. Naturally, it is an equation of nth degree with leading coefficient 1. Hence, it can be split into n linear factors, of course. As all the n roots are before us, it can be written like this. Well, this is equal to x minus x to the power of, this is an equation of nth degree, x power n minus x power n minus 1 into. Now, here you may have to recollect the customary habits of a theory of equations. If an equation of nth degree is there, say a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on, etc. an is equal to 0, then the coefficient of x power n is a naught. Then the coefficient of x power n minus 1, if the roots are known, is sum of the roots. Coefficient of x power n minus 2 is sum of products of the roots taken 2 at a time, and so on. Like that. So it is coefficient of x power n minus 1 is sum of all the roots 1 plus alpha 1 plus alpha 2 plus etc. alpha n minus 1 plus x power n minus 2 into. Now, what is to be written here in these brackets? Sum of the products taken 2 at a time. You are supposed to take 2 to have the product. 1 into alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus etc. 1 into alpha n minus 1, that is alpha 1 plus alpha 2 plus alpha 3 plus etc. alpha n minus 1. Now start to write the products with alphas. Alpha 1 alpha 2 plus alpha 1 alpha 3 plus etc. Then alpha 2 alpha 3 plus alpha 2 alpha 4 plus alpha 2 alpha 5 etc. Then alpha 3 alpha 4 plus alpha 3 alpha, like that. It can be represented with this summation symbol sigma alpha I alpha j 1 less than or equal to I less than j less than or equal to n minus 1 plus minus x power n minus 3 into what should be written there? Sum of the products of the roots taken 3 at a time plus x power n minus 4 into sum of the products of the roots taken 4 at a time. Like that, at last minus 1 is equal to 0. Is equal to 0. As it is minus 1, the last term here also minus 1. Now let us think of the required. What has been required? What is asked here? Sigma alpha I alpha j. That's all. That is, here is the heroine that we want to have. The value of that we are supposed to decide. Now compare the coefficients on both the sides. Coefficient of x power n is 1. 1 is equal to 1. What is the coefficient of x power minus 1? 0. Coefficient of x power minus 2, 0. Coefficient of x power minus 3, 0. And the last term is minus 1. Let us compare the coefficients of second and third terms. What are you going to have? This is 0. Therefore, 1 plus alpha 1 plus alpha 2 plus etc. alpha n is equal to 0. From this, what can you decide? Alpha 1 plus alpha 2 plus etc. alpha n is equal to minus 1. Keep it at a side. Again, coefficient of x power n minus 2 is also 0. That is, this entire thing is 0. And in this place, alpha 1 plus alpha 2 plus etc. alpha n minus 1. What can you write? Minus 1. Therefore, minus 1 plus sigma alpha I alpha j is equal to 0. You send minus 1 that side, so that the required summation is supposed to be how much? 1. Here we are supposed to make use of these two coefficients. You equate this to 0 and equate this to 0 also, so that you will be able to have the required sum as 1. What is the right option? Option B is the right option. And what is the right answer? 1 is the right answer for this question. Let us be ready to go through the next question before us. There is question number 27. He has given z is equal to cos theta plus I sin theta. Then the value of sigma m is equal to 1 to 15 imaginary part of z power 2m minus 1. A big sum at theta is equal to 2 degrees. Theta is equal to 2 degrees. Options are 1 by 2 degrees, 1 by 3 sin 2 degrees, 1 by 2 sin 2 degrees, 1 by 4 sin 2 degrees. Let us have a look over that. What is the actual value required? Given that z is equal to cos theta plus I sin theta, we know that the real part of z is cos theta and imaginary part of z is sin theta. What is the actual required value? Sigma imaginary part of z power 2m minus 1 m is equal to 1 to 15. Of course, at theta is equal to 2 degrees, he has given, let us substitute it at the end. What is this? Z power 2m minus 1 is equal to sigma m is equal to 1, imaginary 1 to 15, imaginary part of, what is z? Cos theta plus I sin theta. That is e power I theta whole to the power of 2m minus 1. That is equal to sigma m is equal to 1 to 15, imaginary part of e power I 2m minus 1 into theta. Let me call this 2m minus 1 into theta some alpha. So it is e power I alpha. What is e power I alpha? Cos alpha plus I sin alpha. What is the imaginary part of that? Sin alpha. Hence, imaginary part of this entire thing is just nothing but sin of 2m minus 1 into theta, right? Yes, of course. So, the term whose sum is required with this summation symbol is nothing but sin of 2m minus 1 into theta. Therefore, sigma m is equal to 1 to 15 sin of 2m minus 1 into theta. We know that 2m minus 1 is an odd number for any natural number m, and in the place of m we are supposed to substitute 1, 2, 3 etc. up to 15. What happens? This is just nothing but, if you take 1 to one side to 2 minus 1 is theta, it is sin theta plus sin 3 theta plus sin 5 theta plus sin 7 theta and so on. The 15th term is 2 15s are 30, 30 minus 1 is 29. Of course, the last term is sin 29 theta. Sin 29 theta. Well, in trigonometry, there has been a good summation regarding the terms like this. If the angles were in AP, theta, 3 theta, 5 theta and so on, 29 theta, like that, there in AP you can observe. Then this summation can be estimated as sin of first plus last by 2, first plus last by 2 into sin of n d by 2, d is nothing but the difference, by sine d by 2. That is the formula. Let us recall the formula required. Sine a plus d plus sine a plus 2d plus sine a plus 3d, like that. If you have a sum like that, it is sine of first plus last by 2 into sine of n d by 2 by sine d by 2. You please recollect this formula. It can be seen in the summation of series involving trigonometric functions, provided the angles are in AP. Yes, let us try to use that formula so that it becomes sine of first plus last by 2, that is 30 theta by 2, into sine of n d by 2. N, number of terms, what is that? 15. D, what is the difference? 2 theta. 2 theta by 2 by sine d by 2. What is d? The difference. Theta, 3 theta, 5 3 theta, and so on. What is the difference? 2 theta. 2 theta by 2. Altogether, this is sine of 30 theta by 2 is 15 theta. Again, 2 will be cancelled. So, again it is sine 15 theta by sine theta. Now it is the right time for us to use theta is equal to 2 degrees, because we are supposed to estimate the required sum at theta is equal to 2 degrees. Get it substituted there. What is going to happen? 15 2s are 30 degrees. So it is sine 30 degrees into sine 30 degrees by sine 2 degrees. What is sine 30 degrees? Half. Half into half. 1 by 4. Total, it is going to become 1 by 4 sine 2 degrees. Is it available among the options? Of course, it is available in the fourth option. That is, option D is the right option, and the answer is 1 by 4 sine 2 degrees. That's the question. The highlight of the question is, you must remember this formula, which can be drawn from the summation of series involving trigonometric functions, provided the angles are in AP. Yes, that is the answer. 1 by 4 sine 2 degrees is the right answer. We shall now see the next question, that is question number 28. If Z1 is a root of the equation a0 z power n plus a1 z power n minus 1 plus a2 z power n minus 2 plus and so on, etc., plus an minus 1 into z plus an is equal to 3, where mod ai is less than 2 for all I is equal to 0, 1, 2, 3, etc. n. That is, mod a0 is less than 2, mod a1 is less than 2, mod a2 is less than 2, mod a3 is less than 2, and so on, etc. up to mod an is also less than 2. With that information given, he is asking about mod z1. For that, he has given us 4 options, namely, in the first option, option A, mod z1 is greater than 1 by 3. Second option, mod z1 is less than 1 by 4. The third option, that is option C, is mod z1 greater than 1 by 4. And the last one, that is option D, is mod z is less than 1 by 3. Let us see what is going to happen. First of all, what is a given equation? That is the given equation. For that equation, of course, z1 is a root, he is saying. It does mean that a0 z1 power n plus a1 z1 power n minus 1 plus a2 z1 power n minus 2 and so on, etc. n minus 1 into z1 plus an is equal to 3. Okay, we are interested to find mod z1. Let us see. See, you're taking absolute values on both the sides. What are you having? Mod 3 is equal to modulus of How could we get this step? we have just taken the absolute values on both the sides, that is modulus on both the sides. We know in complex numbers, mod a plus b is less than or equal to mod a plus mod b. Mod a plus b plus c less than or equal to mod a plus mod b plus mod c. Mod a naught plus a1 plus a2 plus etc. a n less than or equal to mod a naught plus etc. 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 Hence, this can be written individually as less than or equal to mod a naught into mod z power n plus mod a1 into mod z power n minus 1 plus with what step or what authentic rule we have done this step. We have got this step. Mod a plus b less than or equal to mod a plus mod b. Again, mod of a naught into z power n is nothing but mod a naught into mod z power n. Moreover, there has been one important thing in the data. Mod ai is less than 2 for all I 0, 1, 2, 3, etc. That is mod a naught less than 2. Mod a1 less than 2, less than 2, less than 2, etc. Hence it is less than 2 into mod z power n plus mod z power n minus 1 plus mod z power n minus 2 and so on plus mod z plus 1. Therefore, 3 by 2 is less than 1 minus mod z power n plus 1 by mod 1 minus mod z, or this is greater than 3 by 2 implies 1 minus mod z power n plus 1 by 1 minus mod z is greater than 3 by 2, is greater than 3 by 2. Let us cross multiply that. What is going to happen? 2 minus 2 into mod z power n plus 1 is greater than 3 minus 3 mod z. 3 mod z. Let us bring those two things here and send this to that side. What happens? 3 mod z comes this side, plus 3 comes this side, becomes minus 3. 2 minus 3 is minus 1, is greater than 2 into mod z power n plus 1. But you see, modulus of z is a positive real number. 2 into mod z whole power n plus 1 is greater than 0. What do you observe? 3 into mod z minus 1 is greater than 0. Isn't it? 3 into mod z minus 1 is greater than 0. 3 into mod z minus 1 is greater than 0. That is 3 into mod z is greater than 1, or mod z is greater than 1 by 3. Mod z is greater than 1 by 3. Where does it lie? Is it available? Of course it is available among the options. The first option, that is option A, gives us the answer. Mod z1 is greater than 1 by 3. Why it is z1? In the beginning itself, we might have used z1 in the place of z. We have forgotten. No problem at all. z1 is a solution. You can put the same here also. Thereby, we'll be getting mod z1 greater than 1 by 3 is absolutely correct. Hence, the right option is option A. We now deal with the next question, that is question number 29. In this question, it is given that x is equal to a plus ib, x square is equal to 3 plus 4i, x cube is equal to 2 plus 11i, where I is the imaginary square root of minus 1, then what is the value of a plus b? The options are 1, 2, 3, 4, accordingly the option A, option B, option C and option D. It's a very simple question. We are supposed to have A and B individually. If you could add them, the requirement, that is A plus B, can easily be obtained. First of all, what is x? A plus ib. X square. Find x square and equate it to 3 plus 4i. X cube. Find x cube and equate it to 2 plus 11i. isn't it? You need not think like that. It is a simple way of answering if you get one simple idea. What is that idea? Look here. X is equal to x cubed by x square. Any doubt? We're like K here to have both x cube and x square individually. What is x cube? 2 plus 11i. What is x square? 3 plus 4i. Well, let me multiply both numerator and denominator with the complex number 3 minus 4i by 3 minus 4i. Let us see what is going to happen. Multiply 2 into 3, 6, 11i into minus 4i, minus 44i square, isn't it? 11i into minus 4i is minus 44i square, that is plus 44. Next, imaginary part. 11i into 3, 33i, minus 4i into 2, minus 8i, by, come to the denominator. 3 plus 4i into 3 minus 4i. 3 minus 4i is just the complex conjugate of 3 plus 4i. Hence it is a plus ib into a minus ib is a square plus b square. Accordingly, 3 plus 4i into 3 minus 4i is 9 plus 16. 44 plus 6 is 50. This is 50 plus 25i by 25. If you could divide it with 25, you're going to get as 2 plus I. Therefore, x is equal to 2 plus I. But what is x? A plus ib. A plus ib is equal to 2 plus I. Therefore, a is equal to 2 and b is equal to 1. By adding them, you will be going to get a plus b is equal to how much? 3. Is it available? As it is available in the option C. The third option is the correct option. So, right option is C and the right answer is 3. The next question before us is question number 30. If the complex number z satisfying z plus mod z is equal to 2 plus 8i, then mod z is equal to, what is the value of mod z? Yes, just given z plus mod z, it is 2 plus 8, is a complex number, then value of mod z, it is supposed to be a real number, of course. The options are 8, 17, 15 and 24. Let us now find it. What is data? Z plus mod z is equal to 2 plus 8i. 8i. Now, let me take z is equal to a plus ib. Z is equal to a plus ib. Therefore, mod z is equal to root of a square plus b square. Isn't it? Add these two. Z plus mod z is equal to a plus ib plus root of a square plus b square is equal to 2 plus 8i. Now, let us compare the real parts and imaginary parts in this equation. What is the imaginary part here? 8. What is the imaginary part here? B. Therefore, b is equal to 8. Lucky. Keep it at a side. Again, a plus root of a square plus b square is equal to 2. From this, root of a square plus b square is equal to 2 minus a. 2 minus a. Let us square it on both sides. A square plus b square. What is b? 8. B square is 64. 64 is equal to 2 minus a whole square. A square minus 4a plus 4. A square minus 4a plus 4. A square and a square you can cancel. So that, what do you have? Therefore, minus 4a is equal to 60. From which you can directly have a is equal to minus 15. A is equal to minus 15 and b is equal to 8. Thereby, what is z? Z is equal to minus 15 plus 8i. But we want mod z. Mod z is equal to root of 225 plus 64. What is 225 plus 64? 289. What is the square root of 289? It is 17. So what is mod z? The value of mod z is 17 and it is available in the option B. The second option, that is option B, is the correct option and the right answer is 17.